So we will look at some deep learning interview questions today. What do you mean by deep learning? Deep learning is a subset of machine learning that uses neural networks with many layers. So basically you have an input layer, hidden layer, and output layer. Unlike traditional, which often requires manual feature extraction, deep learning models can learn features, so you don't have to do any specific feature engineering. As I said, the architecture of a neural network, one or more, its input layer, one an output input layer, one or more hidden layers, and output layer. So each layer contains new neurons that are connected to nodes in the previous one. Each connection has a weight that is adjusted during training. So basically any neural network is basically a play of and finding the optimal set of weights across each layers. What are activation functions? Activation functions introduce non-linearity in the network. Otherwise, it would be a simple regression network or a network which does linear regression. Some of the activation functions include ReLU, sigmoid, and tanh. Describe the concept of backpropagation. Backpropagation is an algorithm where you take the derivative of the last function with respect to weight, which is called the gradient, and you pass this gradient to the inner layers, which updates the weight. This is used to minimize the loss function. The vanishing gradient problem. What is the vanishing gradient and how can it? Vanishing gradient problem means that the inner layers, the gradient becomes too small as it passes to the inner layers. Some of the weights don't change, so there is no learning happening. So you can use techniques like ReLU, batch norm. So there is another video that which I have made on handling vanishing gradient. What is the difference between convolution networks and CNNs are mainly used in spatial data, such as image processing. Again, convolution layers can be used to RNNs are designed for sequential data and are used in techniques like language modeling. So each is a hidden layer. Each the previous layer's output goes to the hidden layer, and then there's a sequential information. Whenever there is sequential RNNs are being used. Nowadays, you have transformers which are much more efficient than RNNs. We will look at transformers in another video. What are the common applications of deep learning? Image recognition, natural language processing, recommendation systems. Overfitting can be handled in techniques like dropout, regularization, data augmentation, and early stopping. We will discuss about this in a later video. What is transfer learning? Transfer learning, you use a pre-trained on a new related task. So generally what happens is you have learned for a particular task. You will reuse the model, but if needed, you can do some fine tuning. So that is the concept of uh, what is dropout. Dropout is a technique where you remove a certain percentage of the neurons. This allows the neural network to generalize better. So you're forcing all the other layers to learn, not to learn the same part. So you're able to generalize better. What are GANs? GANs are basically two networks, a generator and a discriminator. So generator creates fake data and it discriminator discriminator can distinguish between fake and real data. This computation helps the generate produce realistic can be used in synthetic data generation, uh, supervised, unsupervised. Supervised learning, there's a specific label. Unsupervised learning, there's no specific label. Reinforcement learning involves to make certain decisions under certain desired constraints based on the concept of risk and reward. What is a loss function? Loss function measures the difference between the predicted output and actual output. You can have a loss function like mean square error or cross entropy. The objective is to penalize whenever the model predicts wrongly. Hyperparameters are grid search, random search using techniques like How do you choose hyperparameters for a deep learning model? Grid search, random search, Bayesian optimization. We will talk about these techniques in much more detail. What is the role of an optimizer? Optimizer helps in adjusting the weights to minimize of the neural network to minimize the loss function. LSTM, there are types of RNN. They are based on the use of gates. They are used in language types, but nowadays you have transformers. You might not use LSTM and RNN so much. Autoencoders are used for so consists of an encoder that compresses the input and decoder that reconstruct, used for dimensionality reduction and anomaly detection. Batch normalization normalizes to have another video on batch normalization. So you have the input to each layer has a mean zero and standard deviation of one. How do you evaluate the performance of a deep learning model? Precision recall F1 score ROC. There are other fields like Matthew correlation coefficient. What are the challenges that you see when you are working on deep learning projects? Large data sets, hyperparameters, computational resources. Huh. What are the different gradient descent algorithms? Batch gradient descent calculates the gradient of the cost function with respect to the entire data set, while stochastic gradient for each training sample. Batch gradient descent is more stable. Batch gradient descent is more slow. Stochastic gradient descent can be faster, but a lot more noise. The learning rate controls how much the model changes in respects to the change in the loss in the estimated error as the model. So basically, during the time of grade, when you can do the get when you do when you take the difference of the loss function with respect to weight, how much the how much what is the extent to which the weights get updated, or to what extent, what is the size of um, the learning that happens. A high learning rate can lead to a faster convergence but may overshoot the optimal solution, but a lower learning rate ensures that precise convergence but can be slow. What are vanishing gradients and exploding gradients? We spoke about this. Attention mechanisms. Attention mechanism means you give you understand what is the relative weightage of each words in a sentence. Basically, it means that you focus on specific part of the input sequence. How do you handle imbalance? Data imbalance can be handled with techniques like SMOT, minority sampling, majority sampling, model interpretability. There are techniques like Shapley and line.